Okay, so in this video, we are going to review setting up double integrals and also integration over regions that can be represented as type 1 and also as type 2. So first, let's start with drawing the region and see if we can set up the limits. All right, so my triangle is, it goes through 1, 1. So this would be 1, 1 here. And then we also have 5 ones. So 1, 2, 3, 4, 5, 1. And then we have 5, 5. So 1, 2, 3, 4, 5. Okay, so let me just draw using different colors. So let's say this side is green. Let's say this side maybe orange, and this is blue. All right, so to set up this as a type 1 region, so first of all, we're going to have dy dx. To find the x limits, you're looking at what are the extreme values of x, and those are 1 through 5. To find the y limits, you have to ask yourself, okay, so first of all, does this region look like it's just a rectangle? No, it's not, right? Because this region is a triangle. And so obviously, then the limits must have some variable in them. So if it's a rectangle, then the limits are numbers, but it's not a rectangle. So I want you to remember, if it's not a rectangle, I must have some variable in either both limits or maybe just one, but cannot be just numbers. Now, what variable? The outside variable. So if the outside variable is x, then the limits must have at least somewhere x in them. Okay, so to set that up, you need to figure out what's your bottom curve. So this would be bottom, right? The orange curve is your bottom, and the green curve is your top. Let's see if we can write down the equations. For the bottom curve is a horizontal line, right? And all horizontal lines have equation y equals something. So this is going to be y equals 1. Right? Because it's just 1, y doesn't change, it just stays at 1, and x is anything. So that will be your bottom. So that's y equals 1. For the top, let's see if we can come up with the equation. So first, let's get the slope out of the way. So first ask yourself, is it going to be a line, the green line? Does it go up or down? So when you go from left to right, you're going up, right? And so the slope is going to be positive, and then the slope is just rise over run. So here rise is 4, and a run is also 4. So 4 divided by 4, that's just 1. So your m on the slope is going to be 1. So this is going to be x plus b. Now, what is b? B is the y-intercept. Now, maybe in this case, it's actually pretty easy to see that the line is going to intersect the y-axis at 0. But what if, it's not that obvious? Then you ask yourself, okay, what point, and you only need one point, does the green line have? Well, the green line has a point 1, 1. So let's substitute 1 for y and 1 for x. And then we'll immediately see that b is just 0, which means that the line is just y equals x. So that's just going to be x over here, and that's it. Okay, so we're going to integrate in a second. I want to also set it up as a type 2 region. Okay, so for here, we're just going to go 1 through 5, and then here 1 to x. Okay, now for the type 2 region, what happens there? So I always recommend drawing the picture again because it's going to be confusing, okay? If you try to use the same picture. So again, I'm just going to redraw that triangle. Okay, so 1, 2, 3, 4, 5. Okay, so this is going to be green. Whatever. This is blue. Let's say this is orange. Doesn't matter. Okay, so here we have to think about left curve to right curve. So when we set it up as a type 2, the integration is going to go dx dy, not dy dx. The y limits will be these outside limits. These are extreme values of y, not x. Now, in this particular case, unfortunately, this is kind of a bad example in the sense that you also have y going from 1 through 5, just like x goes from 1 through 5. But generally speaking, look on the y-axis. What are the extreme values of y? So this will go from 1 to 5. And again, because this region is not a rectangle, but a triangle, the limits must have variables in them. What variable? Well, the outside variable. Here, the outside variable is y, so the limits, either both or just one, have to have variable y in it. Okay, so this is left curve, right curve. Now let's think about what is left. Left is the green curve. And we already know that the equation of it is y equals x. However, I told you that the limits must have y, right? And so you can't have x. So what you need to do generally is solve this equation x as a function of y, as opposed to y as a function of x. Now, of course, in this case, it's so easy to solve that just x equals y, but generally you have to solve x as a function of y. So that's my left curve, that's going to be bottom. And then the top is going to be the orange curve, which is the right curve. Now that is a vertical line, and it is at 5, right? So this is going to be 1, 2, 3, 4, 5. So this is vertical line, and vertical line has equation x equals something. In this case, that would be x equals 5. So that's going to go here, and it'll be the same integrand, okay? So I just set it up as a type 2. So this is going to go 1 through 5. This will go y through 5. Okay, now the actual computation. So let's compute it, and we're only going to compute type 1. You can, if you want, to compute it as a type 2, but I'm not going to do that. So my function is 6 divided by x dy dx. Now, just to check that out, let me submit that part just to make sure that that's all correct. Okay, so I just have to have the evaluation done. All right, so let's compute the integral of 6 divided by x with respect to y. Now, because 6 and x are really just numbers, 6 divided by x, because we're integrating with respect to y, that will be a number that you keep. Okay, so that's going to be just 6 divided by x and then y. Just like number is number y, and then we substitute y equals 1, y equals x, and we still have the dx outside. Okay, so 1 through 5, we get 6 divided by x. Then when I substitute x for y, that'll be x here. And then minus 6 divided by x, now I'm substituting 1. Okay, so this will become something pretty easy, I think. All right, so the first one, we're going to simplify x and x will cancel, right? So I cancel that. And so that's just going to be 6. The second one is 6 divided by x. Okay, piece of cake. So this will become 6x minus 6 ln of x. Hopefully everybody knows that 1 over x is log of x. All right, and then the 6 will go there, because so think of this as like 6 times 1 over x. So then 1 over x becomes ln of x. I do not need the absolute value because I have positive limits. And then I substitute 1 and 5. First, let's substitute 5. So that'll become 30 minus 6 log of 5. Subtract parentheses or brackets, whatever, substitute 1. So this will be 6 minus 6 log of 1. So I want you to remember, anytime you see this ln of 1, that is just 0. And any student of mine who will leave this as ln of 1 in the answer will not get full credit, because teachers are very particular about this. You should know that if it's a log of 1, that's always going to be 0. So if I simplify that, that'll give me 24, because 30 I'm subtracting 6, that's going to give me 24 and minus 6 ln of 5. Okay, so let's see if that's right. Okay. Yep.